All right, Unit 8, here we go. This is circles. It's kind of a short unit, and you may think you're kind of familiar with circles, but I'll just warn you now, there's going to be some surprises. But this first lesson's pretty straightforward because it's just a lot of terms and definitions and stuff. It's not so bad. So yeah, this first page of notes, there's a whole lot of definitions that, I don't think you're going to get terribly confused about. Like, I think you've heard about circles before. I think you know that a circle is made up of a center and a radius, that kind of thing. So the definition of circle is that it's all points that are the same distance away from a certain center. So we have a center, and then all of the points that are given, all of the points in the plane, the set of all the points that are exactly that same distance away from that is defined as the circle. And just like polygons and stuff, the circle is just the points that are on it. It doesn't include the points inside. That would be the interior. But we use definition of circle a lot in terms of justifications for things. Now, as soon as I say that, I think I should tell you we're not doing proofs, at least not in assessments this semester, but using the definition of circle is still something that you have to kind of think about. All right, a chord is any kind of segment that just does that, has the endpoints on the segment. Diameter is a special chord that goes through the center. I'm just running through these terms down here. Congruent circles are two circles that have the same length radius. Concentric circles are two circles that have the same center, so I'm drawing another kind of concentric circle there. Polygon is inscribed in a circle. Okay, now I have kind of too much stuff in the way. A polygon is inscribed in the circle if all of the vertices are on the circle, so that would be inscribed. Circumference of a circle is the distance around the circle, and you probably, again, heard this before, that the distance around the circle is defined as, or is known to be 2 pi times r. Yeah, pi is a cool number, and it's the ratio of the circumference to the diameter also. Again, I don't think this is news for anyone, but now I'm kind of letting it out of the bag that this is the day we talk about pi for the first time. Central angle. Okay, so yeah, most of the stuff in this unit is about angles. That's going to probably kind of surprise you. Central angle is the angle like that. It's the angle that is found at the center, so it's a pretty good name for what it is. And an arc is this business right there. That is an arc. We're going to be talking about the length of the arc, and we're going to be talking about the degrees of the arc. Okay, so it's like a little kind of curvy segment. The way we do arc notation is like that, and then it's the shortest path between those two. And that's called a minor arc because it's short and it's less than 180 kind of degrees around the circle. But we can also talk about major arcs that go around more than a semicircle, more than 180 degrees, and they're notated that way. Okay, and yeah, we'll be talking about arc measure. So the measure of an arc is the measure of its central angle. So the measure of an arc, these things are going to be in degrees, and I want to kind of highlight that because when we measure, they're talking about yx. So yx is kind of this arc here, and when we use this little m, we're talking about the measure of the angle. The measure of the angle is in degrees. And I just bring that up because later we're going to be talking about other ways to describe how big an arc is, and it may not be in degrees, it may be in centimeters or something. And this degree of this arc right here is the same as the degree of that angle in there. So that's how arc measures work. All right, total measure of the circle is 360, probably not a huge surprise. Measure of a semicircle is 180. Did we talk about how to notate semicircles? Semicircle notation is also 3 letters. We need 3 letters because here they're talking about EZX. EZX is this semicircle. If I wanted to talk about semicircle EYX, it's a different one. So if you just said arc EX, it would be ambiguous. You have to actually give a 3rd letter on semicircles so we know which one you're talking about. Adjacent arcs, it's like adjacent segments. It's 2 segments that you feel like you might want to add. So you have one arc of a circle and then kind of a subsequent arc that keeps going. They're adjacent. Congruent arcs are 2 arcs that have the same measure, and two congruent circles are the same circle. And so if I have an arc, the way that may look is I have an arc here, and I might have an arc over here. If those are congruent, you actually can mark those with tick marks like we do with segments. Okay. Yeah, here's some other language sort of in the above diagram. ZX segment ZX or chord ZX cuts off 2 arcs, ZX and ZYX. So they're talking about how, I'll just draw this because there's so much other junk in that picture. Here's Z and here's X. There's 2 arcs associated with that. With that chord. There's a chord that goes that way. An arc that goes that way and an arc that goes that way. To name that first one, to name that other one, I need to have this other point Y here. So that's how that works. Wrong button there. Sorry. Oh, things are a little bit rotated. How come I can't? Oh, I want to straighten that. There we go. Okay, so now for some theorems. There's a lot of theorems in this unit, and they kind of pile up. So this, unlike last unit, you're going to get real familiar with the theorem sheet here eventually. In the same circle congruent circles, two minor arcs are congruent if and only if their central arcs are central angles are congruent. So I don't know, not a huge profound statement here, but in the same circle or in two congruent circles, this arc will be congruent to that arc if and only if that angle is congruent to that angle. When we say congruent arcs, we mean not only the measure in degrees, but we also mean the length. So they have to be congruent kind of in every way. That's why we're talking about same circle or congruent circles. Because if it was two circles that were different sizes, because you had two circles of different sizes and you had the same arcs here, or sorry, same angles, those arcs would have the same measure, but they're not congruent because they are different sizes, because the circles are different sizes. So that's why they're saying this stuff about same circle or congruent circles. Okay, and then arc addition, and I said earlier, adjacent arcs are, if you feel like arcs, you may want to add. So you can add these two together to get the great big thing. Again, this might seem like this is leading towards something you might want to say in a proof. And that's an okay feeling to have, but I'll just tell you now, there's no proofs in this part of the year. Sector of a circle. All right, the sector of the circle is a region bounded by two radii. We are going to get to area and circumference, area and volume and stuff this unit, or this semester. Sorry, can't color and talk at the same time. So the sector is this whole region. We don't really mess around with area too much now, but that's coming soon. So yeah, regions and area and stuff is this time of year. So we can find its arc length by finding the measure of the central angle and expressing this ratio as a ratio of 360. So the length of the arc. Length of the arc is a fraction of the circle. So this is it's like a proportion. It's that proportion of the entire circle's circumference. So if I wanted to find okay, well, it's an example, so we'll just get to it in an example. It's a pretty predictable kind of formula. To find the length of the arc, if we know its measure, we just say, well, that measure is, that proportion of the circle circumference, and the circle circumference is 2 pi r. All right, this is a bunch of vocab. I think we could probably do this in class. Yeah, let's do that one together in class. I think you could take what you learned on the previous page and apply all that vocab. That's not too hard, actually. Okay. Calculate the circumference of circle B using circumscribed polygon. Okay, I think they mean inscribed. That's a first old mistake right there. Calculate the circumference of the circle. Okay, so we need to find the circumference of the circle. Oh, there's going to be a lot of formulas this semester. We should probably get used to doing stuff like this. Sorry, I make this formula to think to myself, okay, what is it that I need to find in the diagram or in the problem to be able to answer the question. All right, so I need either the radius or the diameter, it looks like. Well, I have a 30, 60, 90 here, and I have a 12 sitting right there. So I can figure out the side of this triangle here with the 30, 60, 90. I know this is 12 divided by the square root of 3. Remember all that stuff that came up? Some of you don't like the way that's written, so we'll write it that way. 4 root 3, so the radius of the circle is also 4 root 3, or you can think of, or maybe that came from the idea that that's double the short length. So the circumference of this circle is pi times the diameter. A lot of people like to rather see it like this. I don't know, neither one's really better. Or even like this, 8 root 3 pi. Any of those are okay. And yeah, we'll talk in class about how to use your calculator to get what's called exact answers versus approximate answer. This is what we would call an exact answer. If you put it in the calculator and you start to get decimals for things, that would be called a approximate answer. All right, find the measure of each angle. Okay, and measure of each, there's no arc measures, there's just angle measures so far. Measure of each angle given YT. I think they mean measure of arcs also. I think this should be, let's just do this because this makes it a better problem. Let's call this measure and call that measure. Measure of arc, and that should be measure of angle too. All right, what is the measure of all these things? So this is XY. They've measured this angle here. They've told us that this angle measure is 30. That tells us that the arc measure of that is 30. The measure of this angle is 50. So that tells us that if you wanted to know this, the measure of that arc is 50. What do I need? WX. Well, this is supposed to be a diameter. In circles, here's something I haven't talked about. In circles, they need to tell you. Did we talk about notation? Notation, or at least somewhere in the problem, they need to tell you this is the center. You can't, this is one of those things you can't assume from a diagram. You can't assume from the diagram that that is the center of the circle. So they need to tell you something. They did at least tell you that YT was a diameter. So they didn't tell me yet that O is a center. I think that it is. I think I could probably prove that using some other facts about the circle that we could get into. But yeah, YT is a diameter. So I am sure that the arc measure from here to here has to be 180. So using the art of subtraction, I can figure out that this part of the circle is 100 degrees, which is what they asked me. WOT is really easy because I already filled that in, and that came from the arc that was given. And the measure of angle arc XYZ is, now they probably didn't need to give me 3 letters. They could have just said measure of XZ, XZ, and put a little eyebrow on top of that. XZ, well, if these two are congruent and they make a semicircle, those have to be 90. So this is just 120. Okay. Ferris wheel has diameter 40 feet. Okay, I don't love this question, and I think it would take a long time on video, so we will do that in class. It's kind of hard to know what they mean. It's not actually that hard. It's just hard to explain, so we're just going to skip that for now, and we'll do it in class. Use a given diagram to find the measure of each arc. Okay, and again, they didn't do this with the measure. They really should put little m's in front of all those. That's bad notation. Okay, so yeah, these are the same, whatever that is. This is a diameter. Did they tell me that? Yeah, they said DA and BR pass to the center. So that is the center. That's 180 there. If I think about this arc like this. So if this is 30 and these are the same, 30 plus those two things are the same. So the 5x plus the 5x has to be 150. I'll write this out. 30 plus 5x plus 5x has to be 180. So let's say 5x plus 5x. I just want to solve for 5x. I don't really want to solve for x. 150, so 5x is 75. So these are both 75. That adds up to 180. That's good. Measure of arc BC is 75. Measure of arc AB. This thing. This is the rest of this 180. So, you know, this isn't too bad yet. This is 180 minus the other stuff. So that's 65, I believe. And RA is this part over here. That's 180 minus 75, which I think is 105. All right. All right, use the given diagram to find the length of this thing. Okay, we haven't done length yet, so I want to do it. I'm going to make sure I do a length in this part of in the video. Why are we tipping things? All right, so arc length. Arc length is going to be x over 360 times 2 pi r. That's going to be the length of the arc. And there's no good notation for length of the arc. And let's think about what I have in here. Do I have x yet? X would be this. Both of these. Length of FH is what I'm doing first. Length of that thing, measure of that thing I do have. It's 110. This is 110 out of 360 times 2 pi, and I have r. So let's use the calculator. And I'll show you how to use the calculator in class. But on my calculator, I get 44 pi over 9. Now, to get, so that's the length of this. It's 44 pi over 9. Which, if you really wanted to know as a decimal, it's like 15 point something. What about the rest of the circle? That's kind of what this FIH is. There's two ways you could do this. You could find the circumference of the circle and subtract the 44 pi over 9, or you could use the kind of the reflex angle that's in here, and we could say FIH length is, well, it's the rest of the circle, which is 360 minus 110, which is 250 over 360 times 2 pi times 8, which is 100 pi over 9. Yeah, and those two things should add up to the circumference of the circle, which should be 16 pi. We can come back and use that. I could have done, like, these two things should add up to 16 pi. We could have done the second one by subtracting from 16 pi. Okay, then there's some stuff about chords. Find out what happens with the lengths of chords and their properties, and when they bisect or when they're intersected by 90 degrees, or intersected at 90 degrees. Okay, in the same circle or congruent circles, these two things are going to be congruent if and only if these arcs are congruent. So, yeah, this might seem so easy that it's hard at the beginning, but if those two arcs are congruent, then the segments have to be congruent and vice versa. And this, just like that last property we kind of had about the the angle measures and the central angles and stuff, or the arc measures. This could be in the same circle. It could be in two congruent circles. Seems pretty easy right now, but a lot of this unit has problems that are going to come back, or properties that are come back after a long time of not seeing them, and things you have to calculate, and things you have to measure, and things you have to like calculate. And yeah, this is one that can be forgotten about, or it's a trick that I guess people are like, oh yeah, I could use that trick. So just put this in the bag of tools. You're going to need it. If a ray divides an arc into two congruent arcs, then it bisects the arc. So here's what we're saying here. If the diameter is perpendicular to a chord, then xz, so if this is perpendicular, the so what is not only is that a bisector, so if it's a perpendicular, that has to be a if a diameter is a, so it has to go through there. If a diameter is perpendicular, then it must be a bisector. And these two little arcs would then also be equal, which is different than saying this, because now we're talking about xz and zy. Those are not chords of the circle. So this is a separate idea. But yeah, a chord or even a radius that's perpendicular to a chord has to be a perpendicular bisector, and it cuts the chord perfectly in half. So B is kind of the, if you could think about it, B is kind of the midpoint of that chord also. And the last one, the perpendicular bisector for chord, is a diameter of the circle. So this one's saying, if you set up this perpendicular bisector first, and you continue a perpendicular bisector, it must go through the center of a circle. So this is good for when you're trying to locate the center of the circle, or you're not sure, they don't tell you it's the center of the circle. You can be sure it's the center of a circle if you know that this perpendicular bisector of a chord thing is going on. Yeah, and that's how that works. We'll apply some of these today and in class in the first, the warm-up stuff. In the same circle, congruent circles, two chords are congruent if and only if they are equidistant from the center. Yeah, so if this thing is congruent to this thing, so we're saying equidistant from the center. You're making a circle, you got a chord, you're trying to measure how far is that chord from the center. That's measured in the terms of this. This is how far the chord is from the center. So if you've got two chords that are kind of pushed into the circle the same amount away from the center, then this has to be congruent to this. Again, in the same circle or in congruent circles. Draw a circle. Okay, let's do this. This is good. Draw a circle. Okay, using my new tools and my software I don't use in class, I just use for videos, trying to figure out how to do a circle. Great. And radius 12. Okay. And a chord that is 6 centimeters from the center. Okay, so 6 centimeters away is what that means. Then I have this chord like this. So it means that the perpendicular distance from the circle to the center to the chord is 6. And all I know about this circle is that the radius is 12. Okay, I'm trying to find the length of the chord. Trying to figure out how long is this thing. Well, one thing I can do, and people forget about this, is I can draw a radius wherever I want. I'm going to draw a radius right there, and I know the radius is 12. That's very helpful. First trick that people forget about. If that radius is 12 and that other side is 6, I know this actually turns out to be a 30, 60, 90 triangle, and the length of that little part right there is 6√3. And I know that's a bisector because this is perpendicular, so the whole thing is going to be 12 times the square root of 3. Sorry that's so thin. I'll redo that. 12 times the square root of 3. All right. Find x and y in this circle. I will do that one in class. Let's just highlight that. Okay, I'm on the last page. Find the following arc measures. Okay, I think will do this one. This has got some surprises in it, I think. So again, they should have told you that E is the center. They didn't. Sorry about that. So assume they're saying, oh, and notation, that means they should call that circle E. If they use that notation, say circle E, that's like saying E is the center. Okay. Measure of arc GH. All right, well, if this is a diameter, I know that it would cut that arc AH in half if I knew it was a midpoint. Or if I knew it was perpendicular. I think we're missing this information. I don't think we can continue unless we know that's perpendicular. So I'm going to go ahead and put that in there. I'm pretty sure that we have to be told that. Because if that's the case, then this is 44, and I can apply the theorem we just used. So I'm pretty sure they meant to tell us that that was 44. So GH is 44, because now I can do the rest. These other things then are cut in half, or those are equal, and they are part of the rest of this semicircle. So this stuff in here adds up with, if I call those x, I know that x plus 44 is 180. So 2x is 136, x is 68. So CD is 68. That one's 68. And AC, oh, that's interesting. What is AC? That's kind of crazy. AC, wouldn't that have to be the same as DC? Or sorry, HC? I think that's the same as HC. I got a lot of stuff kind of in my way here. This eraser doesn't work the same as the Notability one. That would have to be the same as HC, or maybe this is easier. Let's just think about that as part of GC. GC has to be 180, so this thing in here just has to be, again, 180 minus 44, which I've already done, and that's 136. Okay, so this happens a lot in these circle problems. Just remember things like the semicircles add up to 180, or that the whole thing adds up to 360, and you're cutting things in half and all that kind of stuff. Here's another technique. I want to do this one again because this is also kind of a new technique. This is not exactly like other stuff we've done, so I'll pick other stuff to do in class. But find the measure of arc BD. So I just need to know the degrees of arc BD. I need to know this in degrees. Okay, and there's a lot going on here. That's 6 because it's just simply, what do we call it? Marked congruent. What do I need? Well, to find measure of arc BD, I actually need to know the measure of that angle that I just drew in red there. But that would be the same as the one up here from G to E, sort of. Those whole things are congruent because of the 6s. That would be easy to find if I knew, like, and I know those two angles are congruent, so if I can find one of those, that's fine. Well, look at this right triangle. This right triangle here is a right triangle that I have two parts of, so don't forget your trig. This is simply, let me draw this off to the side. This is simply a triangle where I've got a 5 and a 6. This picture's not great. I've got a 5 and a 6 and a right angle, and I need to know this angle here. Let's call that angle O. I know that what is this, tangent? Tangent of angle O equals opposite over adjacent. So I just need to find the inverse tangent of 5, 6. Let's do that. I get 39 point some degrees. So the answer to this whole thing is going to just be that times 2. I'll make it so you can see my thing bigger. 79.611 degrees. It's 2 of those, because 2 of those would make this whole thing, and that's equal to this. Okay, the rest is homework. I will pick out some homework classes or homework problems to do at the beginning of class. Also, see you then.